truth table, generally we can say that truth table, but here the truth table, or we can say that characteristic table. So in the particular sequential circuit, any particular truth table which represent the particular behavior or functionality of the particular circuit is also known as characteristic table, known as characteristic table. So in the particular truth table we all, so as per the truth table we can understand the working of SR latch. In the particular, in this case, first of all, now we will draw a particular truth table. Suppose first of all we will write down the particular present inputs like S and R. So here are two inputs S and R. So we can write down the first two inputs in the table S and R. Now we can write the present state of the output. So basically, first of all, the particular inputs, the both are the inputs. After that, S and R are the inputs. After that, we put here the present state values. PS means present state. Present state is all about the current value of the output. Right now in current time or present time, what is the output of the circuit, which is known as the current value of the output, or we can say that present state means the output of the particular sequential circuit. The present output is known as present state. So like suppose this is a particular circuit, it means if we apply a value of R and S, then the output of the circuit, the output value of circuit, it means the value of Q, is known as present state. And after some time, when the value of R or S, the next value, when we apply the next value of R and S, then the value of output changes. The new value of the output, or it means the new state, is known as next state, which is represented by Qn plus 1. So in particular truth table, we will start with the particular current inputs. There are two current inputs S and R. So we will mention here S and R. After that, we will put here the value of present state. Present state value represented by Qn. And after that, depending on the value of current values of the input S and R and the value of present state, the output value, or we can say that state, will be changed. A new state will we can get. The new state known as next state, which is represented by Qn plus 1. I want to clarify a single thing here, that sometimes the students make an error in the particular this type of equations or in this type of truth tables, that they assume that the q bar and qn plus 1 is the same thing, but it is very different, because the q bar is the complemented version of q and qn plus 1 is the next state of q. So which is, it means qn plus 1 depending on the value of s, r and present state qn. So qn plus 1 is the next state, it is not the complement value of the qn. So here we have two particular input variables s, r and qn. So three input variables, it means the total number of combination always equals to 2 to the power 3, it means 8. So there are 8 combination: 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So there are 8 combinations: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So first of all, when both the now we will see what are the values of next state when all the particular three input variables are given, like s have first case when s equals to 0, r equals to 0, then qn equals to 0. Suppose s equals to 0, our first case. Now one by one we will discuss all our cases. In first case, when both the values are equal to 0 and the and our present state equals to 0. So when present state equals to 0, that means this 0 is the input for gate G2. Now 0 0 0 0, it means NOR gate G2 have value 0 0. So now our output always equals to 1. 0 0 not 0 always be equals to 1. Now this one input for another gate G1, input for another gate G1. So 1 not 0 always be equals to 0. Again this 0 goes here, again 0 not 0. So now both the states, now our circuit is bistable, formally work as a bistable. It means that it is a there are two stable states. So Qn in starting earlier we have the input value of, oh sorry, we have the present state or the value of Qn is 0. Now after changing both the inputs 0 to 0, now both inputs have the value all equals to 0, then our particular state remain unchanged. Earlier is 0, now all again it is 0. Now if the value, if s equals to 0, r equals to 0, second case, and the value of qn equals to 1. Now second case, if s equals to 0, r equals to 0, and now qn equals to 1. So similarly the input for G2 is 1 and 0. Now the output is 0. Again this 0 goes there, 0 0, again comes 1. So again whenever s equals to 0, r equals to 0, present state equals to 1, the next state equals to 1. It means in both the cases when we analysis both the cases, whenever the value of s and r both have equal value and the value is same value which is equals to 0, both the cases first and second, when s and r both have same value like 0, then next state always be similar like our present states. So in this case, if suppose our present state is 0, the next state always be equals to 0. If our present state is 1, then our next state also 1. So in that particular both the cases, we can say that our state is no change, there is no change in the state. So whenever s, so case first, when both the inputs are same, s equals to r equals to 0, then qn plus 1 always be equals to qn. It means the state is no change state. So that is our first case. And now second case, when s equals to 0, when now second case, case second, when s equals to 0, r equals to 1, then if qn equals to 0,